Okay, that's cool. Kenny, first of all, thank you very much for giving me the opportunity to introduce even more people to this new Hepster language called Rust. It's going to be structured. People, word of advice here. I'm running this on a MacBook Pro, and the trouble, of course, is I only have one screen. So any questions, because I'm running this in full screen mode, I probably will not see. So if possible, either interrupt me if you have any questions right then and there using your voice, or simply put the questions into the chat so that we can answer them actually during the Q&A section. I'm just saying what the crack is so that you know how we're going to do it. Just a short overview. I'm going to, of course, introduce the whole thing. I'm going to shed some light on the language. As I said a couple of moments ago, this is an introductory talk. This is not meant to be for Rust experts. This is not meant to be for Mozilla code contributors, but rather an intro of what this language is all about and why people might consider it for the next project and might love it, actually. I'm going to explain the basics of the packaging system and cargo. I'm also going to shed some light on the toolchain support. I'm going to do a case study in the shape of a web server that I'm going to run locally. And needless to say, I will walk you through the code so that you get a first-hand feeling of what Rust is all about. And then it's Outlook and question and answers. And we should be done by shortly after midnight because normally that presentation takes about 6 hours. I'm joking. It's 30 minutes plus. Let's get started. A little bit about myself. I actually come from a computer science background, funny enough. I did all my degrees in computer science. I did a PhD on reflective operating system architectures, wrote a couple of books on reflection and also on Mark, which is actually the microkernel driving the machine that I'm working on now, because at the very core, OS X is based on XNU, which is a derivative of Mark. Mark, of course, goes back to the CMU project. There are Wikipedia pages about it. Read it up if you're interested. During the PhD, I had my first crush on Linux, and that was kernel version 90.95. So I've been using Linux pretty much from, I wouldn't say day one, but rather 94, 95 maybe. That was also one of the reasons why I helped to set up a Linux user group here in Frankfurt, where I'm living. I serve on the board of that LUG, so I do everything right from making the tea, providing tech support, and doing the admin stuff that is required for such an association. I'm also an Arch package maintainer, so Arch, of course, being the distribution that I run on most of my ARM kernels, if they're not running Android. And other hobbies include the general software development lifecycle, IT security, and other form of black arts. The important bit here, of course, I'm a white hat hacker. So if people want to hire me, they're free to do so, but I'm not into black hat stuff. And if there's still time, I'm the community liaison and solution architect for Redis Labs. Of course, Redis Labs being, full disclosure, the company behind the in-memory NoSQL database. And tiny bit of commercial break here. For those of you who went to FOSDEM, I did a talk in the dev room, in the Rust dev room this year on Redis JSON 2, which is the re-implementation of a DocumentDB on top of Redis. If you're interested in that sort of thing, check it out. I think the presentation is still online. Feel free. And the last bit of commercial break that I'm going to do, of course, I do have my own podcast. It's called Linux In-Laws, in reference to the old legacy called Linux Outlaws. For those of you who are probably have been around long enough, you probably know that there was a podcast called Linux Outlaws about more than 10 years ago, run by Fab Scherschel, as well as Dan Lynch of Ockham fame. And Linux In-Laws is the logical conclusion or legacy of this podcast. It's hosted on Hacker Public Radio. Feel free to check it out. All the details, of course, can be found on linux-inlaws.eu. End of commercial break. Okay, back to Rust. This is actually the essence of Rust. If you've used the likes of Python, PHP, and Ruby, you know what these languages are all about. You program, you execute it, and then you are facing errors because Python will throw an exception at you if it can't understand a type. At runtime, for example, you invoke a method on a class that is not defined. You will get an exception right then, but the thing is basically you will only encounter this at runtime and not before. In contrast to this, you have a second class of languages, Rust, Golang, and something called Raku, which is actually Perl 6. Yes, the butterfly is Camilla, as in the new logo for Perl 6, are compiled languages. And if any of you have used Golang before, you're pretty much familiar to the concept. Same goes for I'm almost tempted to say Java, because Java is a compiler-based language too. And yes, it would be one of the first languages to enforce strict typing, but Rust takes it to an extreme. The idea is to move with these type of language, to move anything. What you normally would do with interpreter-based languages such as Python, PHP, and Ruby at runtime to the compile time, meaning you cut down on development time, because anything that can be flagged and compile time will give you less headache at runtime. This is the overall philosophy behind that type of languages. And the old adage still applies. If you can convince the Rust compiler to generate code, you're almost halfway there. Because if that happens, you have pretty much eliminated quite a few cases for errors already then and there, because if there's one thing that the Rust compiler does pretty well, it's actually error checking in terms of strict typing, type derivations, and all the rest of it. So the idea and the main philosophy behind Rust, to some extent, is moving anything in terms of checking that can be done, that is normally done at runtime, right to compile time, meaning that you cut down on overall development time. Some more information. Rust has just turned 10. The first contribution was done by Mozilla Research on the 7th of July, 2010. The idea was basically, okay, just wondering, just say nay if you don't know what Mozilla stands for. Okay, I'm just hearing silence, so I take it that everybody knows what Mozilla is all about. If you take a look at the commits to something called Firefox, you'll notice that the early versions of the rendering engine called what's called Gecko, I think, if I'm not completely mistaken, were written in C. But at the same time, Mozilla discovered that this implementation had a strong disadvantage, namely the amount of time they were pouring into bug fixing, especially at runtime, when they were running the test cases and the engine simply crashed. So some bright spark at Mozilla sat down and said, sorry, we need a new language. They took a look at quite a few languages compiler-based, because they needed this for performance reasons, of course. But none of the candidates were up to scratch. So a team at Mozilla Research decided to do their own thing called Rust. And this is how Rust basically evolved. The idea was to get C/C++/Java right. Don't quote me on this. This is just my interpretation of the whole situation. But take a look at the basic fundamentals behind Rust. You have a strong typing system. You have compile time optimizations to your heart's content, meaning that the idea is basically to cut down on QA time, on QA effort, meaning that everything that can be done at compile time is done at compile time. This is the overall philosophy. Plus the fact that they had a very close look at Java, Python, and friends, and of course came up with the notion that a programming language itself is great, but without the ecosystem, you're pretty much lost. Best example, if I sit down today and want to write a Python program, I normally take a very close look at what's out there in terms of PyPy packages and simply install the necessary functionality via pip and just write the glue code, because that saves me an awful lot of time in terms of I can reuse other people's code that have been written, tested, and published already. So that's example. A couple of years back, one of my friends basically had the problem of converting, what is it? What was it? Yes, spreadsheets with rosters to something called Google Calendar. For some reason, that company, the company he was working for, had just switched from a proprietary scheduling system to Google Docs, to the G Suite, but they had about 20,000 rosters that they had to convert. The proprietary legacy system was able to produce CSVs. That friend basically put a call to a consultancy that quoted him about a month to do this in some C# fashion or whatever, plus QA, plus kind of doing it correctly, including documentation, all the rest of it. I took a look at what was out there in terms of PyPy packages, and I came up with a solution of using LibreOffice to interpret the CSVs, because LibreOffice, as in calc, can import CSV files. LibreOffice does offer a Python, or sorry, object model, and there's a sugar layer on top called Pion, I think, if I can recall correctly, that simply allows you to access calc worksheets. So it took me about a couple of hours to come up with the necessary Python packages that are required in order to convert the CSVs to a data type that the Google Calendar API, of course, also available as a Python package, would be able to accept. And the friend of mine and we were done within 2 days, including documentation. The idea is, of course, to see what's out there in order to reuse software, and that's exactly the benefit of a very comprehensive ecosystem of packages already existing. And of course, the last but not least point is actually focus on standardization. You'll see this if you take a look at the Rust website, and of course the Crate ecosystem. The Crates, of course, being the modules available already for download and perusal in your projects. Any questions so far? Okay, if that's not the case, let's take a look at some of the details of Rust. Memory management. For those of you who have used Python, who have used Java in the past, you probably have encountered something called a garbage collector, because these two languages, apart from other languages, you don't have to worry about memory management, because in contrast to C, for example, or C++, memory management is done by the language runtime, so you don't have to worry about that. You simply request memory for an object or for a variable at runtime, and then the language runtime will take care of counting, for example, the references to this variable, to this storage block. And if that reference count goes down to 0, we deallocate the corresponding memory and we'll give it back to the operating system. In a nutshell, the details are slightly more complicated, but the main takeaway here is that garbage collection, of course, takes time. If you've ever used Java in Java in the olden days, you probably would have observed one important facts, that's what I'm looking for. Trait is probably the better expression. When you don't when you at least need it, the JVM, as in the Java virtual machine behind Java, stops executing because it's collecting garbage. In a soft real-time environment, that will kill you, for sure, because the least thing that you can, the one thing you want to avoid at all costs is actually is non-predictable behavior in terms of non-deterministic behavior of a runtime environment. So with later versions of Java, that has become less of an issue because you can now tune your garbage collector, but it's still there. So needless to say, using a language system using a garbage collector will have a certain overhead in terms of performance impact. And that's exactly the thing that Rust wanted to avoid from day one. So one of the important traits is actually they don't have a garbage collector. And that has certain implications, which I'm going to go through in a minute. But the main idea was actually to design and implement a language that is optimized for ultimate speed, especially when it comes down to parallelism. And yes, for the last, I reckon, 30 years, there haven't been that many kind of new things. It's just basically the matter in computer science, of course. It's just a matter of borrowing and optimizing already existing things. And say Rust would be one of the examples here. So a couple of rules directly deriving from these kind of paradigms. Each variable at any given time has exactly one owner, meaning you can identify who's controlling a variable. And there's only one owner, not multiple owners, meaning that if ownership changes, the compiler knows about this at compile time. This is the important bit. And ultimately, if an owner of a variable leaves the corresponding scope, that corresponding memory block can then be freed. Meaning that, for example, if you want to pass a value to a function, you normally, especially if you want to modify the variable, something that is known as passing by reference in programming languages, the ownership changes in Rust, meaning that essentially you borrow the variable from the caller. If the borrowing concept, for whatever reason, and I'm not going to go into the technical details, Rust, the documentation on Rust basically is full of examples for this lifetime aspect. Essentially, you can tell Rust explicitly what the lifetime of a particular variable is, so that the compiler doesn't have to guess. Meaning that, and this is the important bit, people, at any given time, the compiler already knows exactly who owns a variable and can make the necessary deductions and assumptions in terms of optimizing code. And this is the main takeaway, because everything that Rust does, well, almost everything that Rust does, is aimed at increasing performance of the overall generated code. This is the main idea behind Rust. Some other characteristics of Rust. It's not a real object-oriented programming language, in contrast to, say, Python, Java, CLOS of olden days, as in the commonest object system, or maybe even Kotlin for the hipsters among us, or Scala, of course, yes. You have something called, similar to Go, you have something called abstract data types. And of course, you can define operations on these ADTs, but you don't have inheritance, you don't have polymorphism, and all the rest of these traits of normal object-oriented languages. The Rust community is working on a pure object model for Rust, but given the ideas or the concepts behind Rust, it just may take some time. Because if you take a look at the one of the main disadvantages of object-oriented languages, best example probably being C++ versus C, there's a certain overhead that you pay for these additional traits of a language, and that is normally performance. So the Rust team or the contributors to the codebase are just taking the time to get things right, which I think is the right way, because they don't want to deviate from the path of optimal performance. Going through the main instructions, enums are way more powerful than in C or C++. As a matter of fact, in enum is almost a type in itself. Structs implement abstract data types, i.e. give you the structure of a variable, and then you can define implementations that work actually or contribute code to these abstract to these structs. Similar to C/C++, but only, of course, type checked, because as I said, this is what Rust mostly is all about. Of course, you do have generics, i.e. generic data types that can be instantiated with a concrete type at compile time, meaning that you are free to derive an implementation for these generics. Once you instantiate it, the compiler knows exactly the amount of memory to allocate and can, of course, make the necessary assumptions when to generate code. And going halfway, traits are comparable to mix-ins in other object-oriented languages, so you're almost halfway there when it comes down to OOPLs. And again, the idea is to do everything you can with regards to strong type checking at compile time rather than runtime. Continuing the overview, you have a hierarchy of implementation units similar to other programming languages. Modules package up structs, enum, implementations for these structs. These are your principal namespaces in Rust. Crates essentially are a collection of modules comparable to packages in other programming languages. And of course, crates.io is similar to PyPy for Python, as in a package repository where you can download source code from, and this is the important bit, people. Any packages on crates.io is source code. You download the source code, it's compiled on your machine, so it doesn't matter whether you're using this on an ARM processor, whether you're using this on a MIPS architecture, or whether you're using this on a plain Intel architecture. You're not putting down binaries. You're putting down source code which is compiled and linked on your local machine with the necessary performance enhancements in place by the compiler. This is the important bit. And the old adage goes, before you in brackets re-implement anything, check out crates.io, because chances are some of the functionality that you need for your project is already implemented on crates.io. So essentially, you simply pull down the crates, write the glue code, convince the compiler to generate machine instructions for this glue code, and then do the ordinary QA, as in quality assurance, and you're done. Don't reinvent the wheel. This is basically the main takeaway here. And of course, we have something called Cargo, which is much more than a simple package manager or make system, because it's essentially a comprehensive package build and management system for your and other foreign code. It's essentially a combination of make, CMake, whatever you want to pick here, and your package manager like npm, like pip, and the likes for other programming languages. Essentially, it allows you to search for packages, to download the stuff, to build libraries, and of course executable programs and all the rest of it. So it's all of these rolled into one. This is called Cargo. Any questions so far? Am I still on the call? Have I lost anybody? No? Yes? Maybe?
I'm still here. You're still here?
I'm just checking whether you kind of fell asleep already or you're still with us. Okay, good. Okay, other language features. Closures are pretty much comparable to anonymous functions, the likes of lambdas in Python and other programming languages. Of course, beloved Lisp comes to mind. Essentially, it's a function rolled up into variable. You have macros, similar somewhat to C macros or macros in other programming languages. The main difference here is that in contrast to other programming languages like C, macros themselves are already strongly typed, giving the compiler the advantage of being able to check type compatibility at compile time already, and thus to produce the corresponding optimized code. Yes, and if you want to do so, and this is kind of an advanced topic, you can manipulate the abstract syntax tree through macros. So to some extent, you are able to do in Rust what you can do in Python with the corresponding package, i.e. write programs that to some extent manipulate the AST or even write program code themselves to some extent. As I said, the main difference here being is that, as I said, macros are type checked by the compiler. So the freedom that you have if you want to manipulate the AST is somewhat limited. Similar to Golang and other modern programming languages, you have multiple multiprocessing and threading models at your disposal, and in contrast to other languages, they are already supported by the standard library, meaning that similar to, for example, Golang, you have a concurrency model at your disposal which allows you to implement multi-threaded programs pretty easily just using standard library functionality. And of course, you have a very comprehensive standard library in functionality comparable to what Python brings along, if not more. So the namespace is std, similar to C++. And of course, the whole thing is documented very well on the Rust website. Very important. So in contrast to other programming languages, you don't have to hunt high and low for external packages because the standard library already kind of provides that functionality for you. Okay, time for the demo. But before we go through the code, okay, let's end the presentation. But before we go through the code, I'm going to demo that, let's go through the code. This is actually a very small web server that simply takes a request on a particular port, and then answers this with a random saying. So let's go through this. I hope everybody can see this. If there's anybody in the call who doesn't see my screen right now in terms of the code, the Rust code, please say so, as in shout. If that's not the case, great. So these are what I'm marking right now on the screen here. By the way, I'm using Visual Studio Code for the people who are wondering. This is one of the standard IDEs for Rust.
Yeah.
So do you have a question? No, okay. So this is essentially, these are the components that I import from the standard library. It's mostly actually network stuff, as in standard net. Then IO functionality, and of course threading, because the web server is actually multi-threaded, and of course a simple command line interface, if you will, that allows the program to invoke external programs. Simple as that. A couple of important things. Similar to C, the main procedure is called main. Simple as that. In contrast to C, it just says that every function is preceded by fn, so that the compiler knows that we are looking at a function, something that is callable from another program. And main, by definition, is the first entry point for the language runtime system after the operating system passes control to it. So similar to C, this runtime system simply sets up environments and environment variables and so forth, and takes care of the necessary memory allocation or initialization, and then it passes control to something called main. As I said, comparable to C. So what we do is actually we set up a TCP listener on localhost. This is 127.0.0.1 at port 8080. And something very important, we call unwrap already, meaning unwrap basically will take a look at the return value of a function and will cause an exception if there's anything wrong with this return function, meaning that you do get around of the tedious null checking. If you've used C before, you probably know if a function returns null, you still have to check the error null variable to see what exactly went wrong. If you're, for example, expecting a pointer, unwrap takes care of that for you automatically. So if this statement succeeds, we then have a listener stored in the variable listener, and what you will see is actually that let defines a variable but lacks an explicit type definition, because the idea is that Rust can deduct the type from the return value that bind gives you back. Simple as that. Only if you want to change this, comparable to cast in other programming languages, for example C, you would have to explicitly state a type. And you would simply do this by appending a colon to listener and then simply stating the type explicitly. Then you have something called a macro invocation, and you can always spot a macro in Rust by taking a close look at how it's invoked, because macros typically end with an exclamation mark. So if you see an exclamation mark, you can almost be certain, unless you apply very advanced magic, that you're looking at a macro here. And println, similar to other programming languages, does one thing: it displays the string on standard out, as in the console output, essentially. And comparable to Python, curly brackets indicate a placeholder. And what this does essentially, it basically says that listening for the connections on port 8080. I could have incorporated that actually in the string, but for some reason I didn't. Okay. Next thing is a for loop, but very comparable to Python. It's essentially it terminates when the incoming invocation reports a end of the line, in terms of the socket is closed for whatever reason. For example, you send a kill signal or terminate signal to the process, then this for loop will terminate. Other than that, basically it will run indefinitely. So this is the idea. Essentially, you're looking at an iterator functionality that terminates upon a certain condition taking place. Stream is the allocated variable, and essentially what this does, match is comparable to a case statement in other programming language, only much more powerful. As I said, I won't go through the intrinsic technical details. This is what an advanced Rust causes for, of course, the programming language documentation on the Rust website. Suffice it to say, match essentially takes care of, are we looking at an successful connection? In that case, the OK branch would be executed, or are we looking at something that went wrong? In that case, it simply prints unable to connect and continues the loop. If the connect invocation from the client side would be successful, it simply spawns a thread and executes in this particular thread the function called handle client. So once this is done, the main loop can continue then right then and there to accept more connections, spawning additional threads as additional connections come in. So what does this handle client do? Essentially, it takes a TCP stream, it reads the stream, and it writes a response, and that's all there is to it. So what the handle read essentially does is it simply takes the content of the incoming message, which is actually a HTTP connection request, or sorry, HTTP kind of get or well, rather get rather than post, and any payload in this is simply printed out to stand it out, and that's exactly what this OK branch does of the match, because the match simply takes an array, which is defined up here, and it will spot something very interesting, because here we have to tell the compiler, now look, stream as well as buff, I'm going to change these in the scope of handle read, meaning that the compiler cannot assume that that these variables are read-only. Especially the MUT as a mutable in the let statement indicates that this variable, after the initialization, will be changed by the code below, and that's exactly what this match stream does, because it passes the buffer to read, and the buffer expects. The read expects a buffer that can be changed. Of course, what read does, it takes the content of the TCP packets and stores it into the buffer. That's all there is to it. And needless to say, this is a shortcut, because normally you wouldn't use a fixed length buffer in this function, but this is of course not hardened code. So for the purpose of simplicity, I left it at that. So essentially what this OK branch does, it takes the payload and simply prints it out. Error, of course, says, sorry, there's something wrong with the stream, exit. Okay, once the incoming HTTP request has been decoded, now it's actually time to invoke handle write. And what handle write simply does is it invokes an external program called user local bin fortune. And for those of you who are old enough, yes, that goes back to the olden Unix days when fortune was able to tell you a cookie, or to give you a cookie, as something like a pun, something like a cookie, simply print it out and send it out, and it's taken from a cookie from a so-called fortune cookie database. That's the whole purpose of this external program. What is important here is we tell the operating system, now look, we want to invoke a program that is stored under user local bin fortune. We want to get its output, and then we assign the returned standard out content to something called outp, which is a string which contains the saying of the day, the fortune cookie itself. We then have to, for proper HTTP handling, we have to transform this to UTF. We have to transform this from UTF-8 to ASCII, and that's exactly what this second statement does in line 45. And then we simply wrap this into a HTTP header, or rather body, and this is what you see on line 46 and 47, so that it can be processed on the client side, so that the client side doesn't stumble across malformed HTTP headers and payload definitions. We then basically transform this from a string to a byte stream, and that's program, and that's line 48, and then we simply write this to the stream, again indicating whether sending the response has failed or not. And this is all there is to it for a very simple web server. So let's do one thing. Let's check it out. Funny enough, this is already kind of running. So let's do this from the beginning. And this is of course not clean. Sorry, this is of course not clear, but clean. This is actually a functionality of the build system called Cargo. Essentially, it builds the target area, and the target area is the file system hierarchy where the executable is built. Cargo defines, or Rust defines rather, to be more precise, Cargo defines two build types, namely release, and if you don't specify release, it just builds a debug type with all the a debug release with all the symbols still in the code. And release basically means a different optimization stage in terms of better optimized code, and of course symbol definition stripped and all the rest of it. So let's build this for release. Just takes its time, and it's done. So when I execute this now, and now it's listening for connections on port 8080. I hope everybody can see this, that the font is large enough. Better make it a little bit larger. I hope this is better now. And now let's run this. All I have to do, I'm using curl. I could do the very same in web browser, but what the heck? We are hipsters using the command line, so that's okay. So curl, of course, simply invokes the web server based on the HTTP prefix, and this is basically how it's done. You see the HTML body, and you'll see the payload as in returned by the web server. And of course, needless to say, you do get the printout as defined by the code on the command line as such. Okay. If there are no further questions, let's continue with the presentation. Okay. You already saw Visual Studio Code, which I think is one of the better IDEs for Rust development. Of course, there are plugins for IntelliJ. There are of course plugins for Eclipse for those people who still use Eclipse. You never know. And of course, all of these do provide full Rust language server support. Rust language server essentially is the link between your IDE and the Cargo built-in execution system. Essentially, it allows you to do debugging right from the IDE and so forth. As it's a standard kind of component, it's kind of vital for gluing together the IDE and the ecosystem provided by Cargo. I think there's a trend basically to do away with the RLS, so stay put. I have seen a couple of architectural proposals that directly tie Cargo to the likes of Visual Studio Code without the need for an RLS. Of course, you do have the standard compiler and Cargo downloadable from rustlang.org for your particular CPU architecture. What is important here, the main Rust differentiates between, I think, a couple of tiers when it comes down to CPU architecture support. Intel, of course, and some of the ARMs already kind of being tier 1, but ARM v5, my beloved 32-bit ARM that I use for some of my zoo, are just experimental. So it's still on my list of things to do, basically, to get the toolchain up and running for v5. It's a supported architecture, but it's not done. It's not exposed. Let's put it this way. As much to a proper QA cycle as much as the other tier architectures. For the details, of course, there's certainly the Rust website that is able to tell you all the gory little details should you be interested in that. And of course, you can download the compiler and other toolchain components from the website, but most of the time, your operating system package manager of choice should be able to provide you with corresponding compiler packages too. The main difference, of course, being depending on your operating system, that you are bound to older versions. If you resort to the operating system provided packages, rather than if you download the toolchain, you have the choice of 3 tiers. Essentially, you have a stable version, you have a beta channel, and you have a nightly build. And of course, these different, and Cargo allows you to change between these different channels, giving you early access to the latest and greatest compiler features, because Cargo Nightly essentially gives you the hot shit, as in the stuff that has just passed through the corresponding kind of committee decisions, but is far from being implemented in any mainline compiler, part of the operating system repo package, part of the operating system repository packages. Of course, you do have full support for both GDP and LLDB for those hipsters among us who have resorted to CLang or LLVM to be more precise, rather than kind of GDB. And of course, supported platforms include Linux, OS X, and Windows. I kind of already touched upon the hardware platforms. 32-bit Intel, 64-bit Intel would be the preferred CPU architectures of choice, complemented by 64-bit ARM these days. These slides are slightly older. I think V8 now is a tier 1 architecture now too for the Rust project, but certainly ARM 32-bit, MIPS, and PPC are not fully Q8. Again, details on the Rust website if you're interested. Conclusions almost. The good sides, a strongly typed high-performance language, that should be clear by now, a comprehensive ecosystem, we already talked about this, and that was the overall purpose of Rust when it was invented. Ideal for secure system programming, because yes, we are looking more or less at a low-level language comparable to C, maybe even C++, and this is where the ecosystem comes into play. If you want to do something fancy, you more or less rely on the ecosystem. The ecosystem is quite comprehensive, as I showed before, but at the very core, Rust is something for systems, similar to Golang to some extent. The cons, yes, it's a steep learning curve. It took me about a year to get there where I'm now. Given the fact that I've been using programming language for the last 30+ years, that may tell you something. It's certainly not a programming language that you want to pick up if you are a beginner starting to learn programming computers, because this is not your language of choice. There are other languages much more prime for this, like I'm almost tempted to say Python. But Rust is certainly not the language of choice that you want to start with in your career of programming, unless you come from a quantum physics background or have dealt with quant trading or something. Then anything is a game anyway, and you shouldn't have any problems. But the majority of us basically do not come from this background, so take it with a grain of salt. It's not a real object-oriented programming language, so it does depend on the use case. If you need strong OOPL features, you may want to wait, or you may want to pick another programming language. And as I said, it's not suitable for learning programming. Again, these are my observations. Your mileage may vary. This is something that I encountered when I started to learn Rust quite a few moons back. Where's Rust used? Quantum server. Any of you who are using Firefox, yes, you're using Rust. I reckon more or less on a daily basis. the project switched to Quantum, I think, with Firefox 56. At least for me, that was the point in time when I noticed a significant speed up when it came down to rendering websites. And to a great extent, I reckon this is down to better parallelism inside the rendering engine. Tor uses it, or at least in parts. The idea is that Tor at the moment is mostly written in C, but the project is taking a very active look at Rust going forward and will, if I understand this correctly, migrate more and more portions of the code base from C to Rust. Azure uses it with something called IoT Edge, which is the Internet of Things offering from Edge. There's something called the new shell. So if anybody of you using Linux, feel free to download it. If you're using your favorite package manager. New is a shell, so I wouldn't say it's ready for prime time yet, but I've been using a beta for the last couple of months and it looks pretty okay. It's getting rapidly in popularity, so check it out. And of course, there's a user space WireGuard implementation by the name of Borington, which is also written in Rust. Yes, more and more Redis modules are written in Rust too. Redis JSON JSON 2 probably being the best example. So even inside Redis Labs, we are moving from C to Rust for the language of choice to implement new modules or re-implement old ones. And of course, there is something called the kernel module framework, which is probably worth going into a little bit more detail now. So let's take a look at history. There's a famous Linux kernel mailing list post dated 19th of January 2004, where a guy called Linus Torvalds, I reckon for most of you that name should ring a bell. He invented some sort of operating system a few years back, has gained some sort of popularity, runs on tiny devices right up to mainframes. The rest is history. There are Wikipedia pages about this, so look it up. The very interesting observation here is that Linus already in 2004 did make the remark that C++ doesn't exactly work for kernel modules. Apparently, they and the chaps tried it, and the comment is that it's a bloody stupid idea because, and this may be subject to debate, but I reckon he certainly has a couple of points here. C++ compilers are not trustworthy in terms of, yes, exception handling is broken. That has somewhat changed within the last few iterations of the language standard, but it still fundamentally still holds. Without a proper exception handling, you're down to the stuff that C offers you, so there is no real benefit here for using C++. And especially, and this is basically how C++ does it halfway, it kind of tries to do some of the memory management for you. In terms of kernel technology, that's not great. And yes, this is probably, the last statement is probably something I would disagree with, that you can actually write object-oriented code with C. Quite a few people have tried it. JTK and probably being the best example, if you take a look at the G-object model, if you've been exposed to any proper object-oriented language, you will spin in your grave. But this is a very personal opinion. So anyway, let's go not into this. But the first two statements certainly have value here. So the idea is going forward that you may be in the future be able to write kernel modules in Rust rather than C, with all the added benefits, especially from a compile time perspective, that Rust brings with it. The idea is basically to use libffi as the foreign function interface for automatic C bindings generation, because if anybody of you have looked at the kernel, this is plain C. So you need a component that actually is able to translate Rust to C bindings. And this is basically where FFI, as in the foreign function interface, comes in handy. There's a great implementation for the kernel interface. The kernel does have a very detailed module interface that allows modules to talk to the kernel. For the details, please take a look at kernel.org and to the corresponding documentation as part of your kernel source tree. It's all documented actually in documentation once you untar the tar file. At the moment, it's only AMD 64 support, so it only basically supports Intel 64 bits. Other architectures are work in progress, especially given the fact that projects like Fuchsia are looking at Rust very detailedly. Of course, Fuchsia is not based on Linux, goes without saying, because it's a new kind of implementation from Google for as a successor of Android, but stay put here. It wouldn't surprise me if ARM would be kind of next here. Let's put it this way. Very important. You need a nightly branch. You need a nightly channel in terms of tooling support, and you are bound to CLang. You cannot use GCC because this is not supported at the moment. That has mainly to do with the fact that LLVM is used as a backend for the Rust compiler, as in Rust C. The URL is down there. Feel free to check it out. Some pointers. Of course, there's rust-lang.org. This is your go-to source for any documentation for anything related to Rust as a programming language. Very important. You have books, you have documentation, you have the whole standard library documentation on that website. Max yourself out. Crates.io is your crate registry. Anything that Cargo pulls down, unless you tell it otherwise, is coming from Crates.io. You have the source code on GitHub. There's a mailing list associated with a website called thisweekinrust.org. I would, if you're interested in anything going on with Rust, this is certainly a mailing list worth subscribing to. There are two podcasts one of them called newruststation.com. Unfortunately, the guy who did it discontinued it, I think, last year, but the back catalog is still online. And people, if you're serious about Rust, this is your podcast to download and to listen to. It has helped me a lot to get grips on the language, and some of the finer aspects are really detailed down there if you are stuck with the official documentation on the website. It's a go-to source. As I said, unfortunately, it's been discontinued, but the back catalog is certainly worth listening to. There's also something called ruststation-station.org. It's an regular podcast, but it's still active. It's mostly Rust core related, so you will have quite a few proposal discussions and so forth on that podcast, but it's worth checking out, I reckon, selectively. And of course, there's request for explanation.github.io podcast, and that's a weekly discussion of Rust RFCs. The community process is somewhat similar to, for those of you who know Python, there are PEPs in Python, as in Python enhancement proposals. RFCs in Rust work similarly. Essentially, the way it works, some bright spark comes up with an idea and puts it up to discussion. And then the community decides to either change this, go forward with it, or simply say, sorry, brain dead idea, let's dump this. And of course, the podcast then basically goes through this on a weekly basis. And needless to say, the web server I didn't write myself, but rather it was borrowed, as you normally would do, being a proper artist or scientist or whatever, from somebody else. And this is basically the URL that I use for the code bases that I then amended subsequently. Okay, This is now your part where you can ask any questions. And when I say any questions, of course, I mean Rust related. So I won't be able to tell you next week lotto numbers. I do not know when COVID-19 goes away. So just keep it Rust related, but I'm more than happy to answer any of your questions now. No questions. Everybody's clean?
Sorry. Have you heard of the Safe Network? SafeNetwork.tech.
No.
It's a very ambitious project. Some would say it's trying to reinvent the internet.
Okay.
Problem with security on the internet is servers. That's where all the.
Funny enough.
They want to get rid of servers. Everybody's a client. Now, to tell you the full story about MadeSafe would take me several hours. So I'd suggest you maybe get on over to safenetwork.tech and check it out. However,
Thank you.
About 4 or 5 years ago, they were struggling, and they were in C++. They changed over to Rust, went from, I can't remember the exact figures, but I think it was something like 120,000 lines of code to about 15,000 lines of code, and speeded up the development process immensely.
No surprises there.
Yeah,
okay.
There is a big Rust implementation, and it's happening. Well, it's headquartered in Scotland.
Interesting. Okay.
It happens all over the world, but for many reasons, not just the fact that it's written in Rust, I would really advise checking out safenetwork.tech.
Thank you. Yeah, we do.
The company that runs it is madesafe.net. So please check out.
It's interesting because you have quite a few mesh-based proposals floating around, but that's the first I'm hearing about a Rust-based implementation. Interesting. Will do. Thank you.
One of the questions that people put in the bank earlier is, what is your perfect use case for Rust?
Let's take a look at the questions. Anything you want to do in C or C++, but you're struggling, or you're stuck for time, or you want to do it properly? I'm almost tempted to say, or where Golang fails. Sorry, this answer is slightly biased, but that's my opinion on the. I mean, sorry. It's Rust is not your CLOS or your fancy AI Python domain-specific framework. No, this is not what Rust is for. Rust is a systems language aimed at doing things fast with a proper ecosystem. If that answers the question.